So this is our introductory lesson into section 4.4, proving triangles congruent. So we're going to look at 5 different ways to prove triangles congruent with only 3 pieces of information. So the first way we can prove triangles congruent with 3 pieces of information is side, side, side congruence. So we'll have our first set of congruent corresponding sides. We'll have our second set of congruent corresponding sides. And we'll have our third set of congruent corresponding sides. So this is information that you would be able to find within a single triangle. So if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent, and we can write a congruence statement. So for this particular situation, remember when you name the first triangle, you can put the letters in any order that you want. But when you name the second triangle, you have to match up corresponding pieces. So A is at the vertex of the double and triple marked side. So in the other triangle, that's F. B is at the triple and single marked side. In the other triangle, that's D. And C is at the corner of the single and double marked side, and that corresponds to E. So you have to make sure that you're matching up your corresponding pieces. So if you can get 3 sides of one triangle congruent to 3 sides, corresponding sides of another, then our triangles are congruent. Now, this next one is one that you have to be very, very careful with, because if you don't get it in the proper position, then it doesn't work. So this one is side angle side congruence, and the big part about this is what is meant by included. So if it is included, then it is between the other 2 items. So with this particular set, you will have to be given a first set of congruent sides. So we would have our first set of congruent sides, and you would have to have a second set of congruent corresponding sides. And the angle that has to be identified as congruent has to be the angle that is between them. So it has to be the angle that is between, sorry, the angle that is created between our sets of corresponding sides. So when you look at this and you write it out the way it is, we have a side, we have an angle, and then a side. If you have 2 sides and an angle, but the angle does not fall between the sides, then this does not work. It has to be that our angle is included between our 2 congruent sides. So it has to be the side, then the angle, and then the next side. So they all have to flow together in that pattern. And if that happens, then the triangles are congruent. So our congruent statement for this particular set of triangles is I have triangle GHI. My angle G is at the corner of the single marked and unmarked side. So in the other one, that's going to be K. H and L will be my congruent angles. And then my I, which is at the corner of the double and unmarked side, will match with J. So the next one also has that phrase of included, but this time it's referring to a side. So we're going to have 2 angles and the side that is between them. So when we look at this one, you're going to start with your first set of congruent angles, and then you will have a second set of congruent angles, And then the side we have to have identified as being congruent has to be the side that is between those angles. So in order to be considered included, it is between them. So when you look at this information, we have our angle and then a side and then another angle. Let me put that in that side so you don't confuse it with the vertices. So we have our angle, our side, and then our angle. So ASA, angle, side, angle. So our congruent statement, because once we get that, then the triangles are congruent. So our congruent statement, I have triangle MNO. My angle M is identified as being congruent to P. My angle N by the third angle theorem will have to match R. And my angle O is identified as being congruent to angle Q. So triangle MNO is congruent to triangle PRQ. Make sure that you are matching up corresponding parts when you're writing a congruent statement. So our next one also deals with having information, but this time it is the non-included side. So this is also two angles in one side, but this time our side is not between them like it was in the previous set. So this time we're going to have our first angles marked as being congruent. We will have our second set of angles identified as being congruent, and then we will have a side that is only connected to one of the two congruent angles. So this time our side only touches one of the two congruent angles instead of both of them. So if I have two angles and the side that is not between them, then I still get a set of congruent triangles. So angle, angle, side. I have an angle, and then a set of congruent sides. So I have my angle, and then the side. So notice the placement difference between this one and the previous one. So we have our triangle. If I have S, T, U, my angle S was identified congruent to V. My angle T will be congruent to W, and U will be congruent to X. Now, the next one only has two letters within its name, but you can't get these letters without a certain type of triangle. So this one requires that we have right triangles. This only works on right triangles. So a right triangle is the only type of triangle with a hypotenuse. So hypotenuse leg only works for right triangles. And with this one, you're going to have the hypotenuse. Remember, by definition, the hypotenuse is our longest side, and it will be opposite the right angle. So this is our hypotenuse. So the hypotenuse of one triangle will be congruent to the hypotenuse of another, and we will have a leg. Remember that the legs are the sides that create the right angle. So if we have a right triangle, that's first requirement, and we have a set of congruent hypotenuse and the set of congruent legs, then we can get that the triangles are congruent. So the only time I can have an angle, then a side, and then another side without the angle in between is if we have a right triangle and one of our sides is the hypotenuse. So if we can get that, then we can get that the triangles are congruent. So in this case, triangle ABC is congruent to triangle. My angle A corresponds to X, B corresponds to Z, and Y corresponds to, oh, wrong letter, Y corresponds to the C. So when we're working with identifying congruent triangles with three pieces of information and proving triangles are congruent, we also have to use some additional information. So it may be beneficial to you to kind of make a useful information notes page. So there are certain things that will not be automatically marked for you in a set of diagrams. So we have our 5 ways to prove triangles are congruents. We need to get sides and angles, or in the case of hypotenuse leg, remember that this one requires that we have a right triangle. So we have to get a right triangle to use that one. So just keep in mind the reflexive property, the definition of midpoint, the definition of bisector are converse of the base angles theorem. For angles, we often use vertical angles, rarely, but occasionally we'll use the linear pair or the triangle sum theorem. Bisector, perpendicular right angles, the right angle congruence theorem. Parallel lines always will be identified so that we can get congruent angles, and of course our base angles theorem. So we're going to need to use this information as we go through the examples. So in this set of problems, we are going to be asked, is it possible to prove congruent? For the ones that we answer yes, we have to state the postulate or theorem that we would use, and we're going to write a congruent statement. The explain your reasoning, so anything that I identify that's not already marked will be my explanation of my reasoning. So when I look at this first question, I see that I have a set of single marked sides. I tend to use a letter S for sides, and I usually only do the S's and A's on one triangle. And then I have a set of double marked sides. So this is my second set of sides, and that's all that's marked in the picture. So now I think back to that previous page and things that I might get, and one of them is the reflexive property. So anything can be congruent to itself, and this is used when we have a shared side. So if I apply the reflexive property, I can get that this third shared side is congruent, and I now have side, side, side congruence. So this one is a yes. And we're going to write a congruent statement where we name the triangles. So I have triangle X, Y, Z. My X is at the vertex of the single and triple marked side, and the other triangle, that's Z. My Y is at the vertex of the single and double marked side. On the other triangle, that's W. And the third angle of that other triangle is X. Problem 2, I look at the marked information, and I see that I have a set of angles identified as being congruent. I see that I have a set of double marked sides identified as being congruent. And then, like the previous problem, we have the reflexive property will allow us to identify that this shared side that's between them is also congruent. So I now have 3 pieces of information. Unfortunately, it is not one of my ways to prove congruence. So I need side, angle, side. My angle has to be between them, since I would need the angle between my sides, not the angle that is only connected to one of them. This one is a no. So in order to do this one, let me fix that so you can actually read it. We need side, then the angle, then the side. This one has the angle followed by 2 sides instead of being included. So this angle is not included. Next question, we look at our information. So we have that set of marked angles. We have our double marked sides that is given to us. And just like the two previous questions, we have that shared side. So just like the two previous questions, we can use the reflexive property to get that side is congruent to itself. So now if we look, I have a side connected to the angle, which is connected to my congruent side. So this time, when I look, my side is connected to the angle, which is connected to the other side. So we have side angle side congruence, and this one is a yes. So we can name the triangles. The first one I can name any order that I want, so H, K, J, and I have to match up my corresponding pieces. H is at the vertex of this double marked and non-marked side, which corresponds to L. K is at the vertex of the double and triple marked side, which corresponds to J. And J is at the corner of the unmarked and triple, which corresponds to K. So we're going to continue to look at this same set of directions for the next several examples as well. Is it possible? If so, state our postulate or theorem, write our congruence statement, and anything that was not provided, we explain our reasoning for why we get it. So in our next question, I start in with my given information. So we were given a single marked side in both triangles. We were given a double marked side in both triangles. Now that's the end of my given information. So now I think back to that list of often used items and I look, this time I'm not sharing a side, so I can't get that third set of sides. But when I look at the angles here at the center of the picture, we have vertical angles. So I'm going to use my vertical angles theorem to get that these angles are congruent. So now if we look at the information, I have a side with the angle and then the side. So we have side, angle, side congruence. So yes, these are congruent. We name the first triangle any way that we want. And then when we name the second triangle, we match up the corresponding pieces. So A corresponds to T, D corresponds to S, and K corresponds to K. Be careful with problem 5 because there are a lot of markings. So when we look at all of our markings on this one, there are quite a few. We have, if you look very closely, at that tiny tip there is an angle, and at the tiny tip of the other one we have an angle. We have a double marked side, and we have a single marked side. Now, we have to be careful because our little angle that's right there does not actually connect to both of our two previous sides. So if we look at how that lines up, it's the angle, the side, and then the side. So that doesn't match up. However, we have one more additional piece of information. We have a right angle. Remember, we have that theorem 3.3 that says we don't just get one right angle at that intersection, we're going to get multiple right angles. So this means that we have a right triangle. So this means when I'm looking at my information, I look to see if I have the hypotenuse, which happens to be my double marked side, and a leg, which happens to be my single marked side. So we can actually get these are congruent using hypotenuse leg congruence. So I have the triangle JKM. The J corresponds to N, K corresponds to K, and the M corresponds to L. Not every right triangle is going to be hypotenuse leg, though. Problem 6, we look at our marked information, and the only thing that is marked, we have that first set of sides. We have a single right angle, but we get to apply the fact that we get multiple right angles using that theorem 3.3. So this means that we have a right triangle. Also, like several of the problems on the previous set of examples, we have a shared side, so we can use the reflexive property. But if we look, both of these are legs, so we're not actually going to use the hypotenuse leg theorem, but what we can use is we can use the fact that all right angles are congruent, and we can get side, angle, side. So just because it was a right triangle, none of our marked sides turned out to be the hypotenuse. We happen to have both of the legs identified, nothing on the hypotenuse, but all right angles are congruent. And this was side, angle, side congruence. Spelled that backwards, didn't I? Let's fix that. So this is, yes, they are congruent triangles. Triangle ART. In the other triangle, A corresponds to A, R corresponds to R, and the G corresponds to T. So continuing along with the same process, looking at our information. So in this next one, we have those single marked angles. Then there is a set of double marked angles. So we have an angle, and we have an angle, and that's the end of our labeled information. But like several problems on the previous page, we have a shared side, so we can use the reflexive property. Anything is congruent to itself, so we have a side. So we have two angles and a side, so pay close attention to where that side is. So I have my first angle not connected to the side. I have my second angle that is connected to the side. So this is angle, angle, side. So that side is only connected to the second angle. So when we look, I have my first angle, I have my second angle, and only the second angle is touching the side. So this is angle, angle, side congruence. So this is yes. I name my first triangle JUI. My J corresponds to the L, the U corresponds to U, and the I corresponds to I. Now, there are a lot of triangles in problem number 8, and you have to be very careful about which ones you're identifying as being congruent. So we can see that there is a set of single marked sides, and we can see that there is a set of right angles, but the triangles that have these are overlapping each other, so you may want to actually pull this picture apart. So I'm going to pull my information over. So I have the M, I have the O, and the U. So my MO is my single marked side, and my right angle is at O. And then my other triangle, I pull it over to the other side. So this one has the CU. So So I have the C, U, and O, and this one has the right angle. So it may be beneficial for you to look at them kind of pulled apart. So that's my markings. But when we look, before I pulled them apart, they both share this side OU. So just like some previous problems, we can use the reflexive property. Both of them have the same side OU. So that is my reflexive property to get that as congruent. We keep in mind that all right angles are congruent. We also happen to have a right triangle. Now, none of our marked sides are actually the hypotenuse, so we're not going to use hypotenuse leg. But if we look at how this is labeled, we have our side connected to the angle, connected to the other side. So this is side, angle, side congruence. So we have the triangle MOU. M corresponds to C, O corresponds to U, and the U corresponds to the O. Our last triangle, we look at our given information, and we have a set of double marked sides, but that set of double marked sides has something additional on it. It has this set of arrows, and remember that this set of arrows is to tell you that you have parallel. So when we look at this, we are currently only identified as having a set of sides as being congruent, but we do have parallel. So when our two triangles are completely between the parallels and we get this X in between, we can use the alternate interior angles theorem. So my angle A, if I go down that same transversal to the other parallel, will match up with angle T. And my angle C, if I follow that transversal down to the other parallel, will match up with the angle O. And now I actually have two sets of angles, one on each side of that side. So we can use our angle, angle, side congruence. You also have one other thing that you could have noticed. You could have looked in here at the center and said that this was vertical angles, and we could have used our vertical angles theorem. So that would have actually given us a angle here, and we could have also proven these triangles were congruent using angle, oh, I had this first one wrong. So we originally have our angle, side in the middle, and then our angle. So we have our two angles with the side in the middle. Or now, if we use the vertical angle, we have our vertical angle, we have one of our alternate interior angles, and then the side. So we can use angle, angle, side on this, or we can use angle, side, angle congruence to get that, yes, they are congruent. My triangle CAR, the angle C corresponds to O, the angle A corresponds to T, and the R corresponds to R. Last set of examples for this set. When we look at our information that we are given, so we have a set of right angles. So we can either use the fact that all right angles are congruent. We can also use this to say that we have a right triangle. We have a set of sides identified as congruent, which happens to be the hypotenuse. And then we have a situation we've had in multiple problems. We can use the reflexive property. to get this shared side identified as being the same, and it happens to be a leg. So we can actually get this particular one by hypotenuse leg congruence. So we have that these are congruent. We have triangle PTR. The angle P corresponds to M, the angle T corresponds to R, and the angle R corresponds to the T. Now, you have to be super careful when you're looking at the markings. So I have a single marked side, I have a single marked side, and I have a single marked side. I have a double marked side, I have a double marked side, and I have a double marked side. So when I look at these, this is not congruent. So I cannot get my corresponding sides congruent.